We will solve log equations today. So a couple things, I will start easy and then it's going to get a little icky. A couple things you need to remember. You need to check for valid solutions. What does that mean? After you get the answer, you need to go back and plug it in the original equation and see if the expressions inside the log or the argument is positive. If it's positive, you're good to go. If it's not positive, that means that can be it. Okay, we will start by rewriting this in exponential. So the base is always the base. Raised to the power of 3 equals the argument. So 3 to the power of 3 equals the argument. So 3 cubed, 27. That is t. And clearly, if you go ahead and you plug 27 in for t, that gives you a positive expression right there. Therefore, this is a good solution. Okay, for the second one, you need to subtract 6 from both sides before you do anything. So take away 6, you have log of t equals 2. Now you rewrite this. So remember, when the base is not there, the default base is 10. So 10 to the power of 2 equals t. 10 squared is 100 right there. And when you go ahead and replace 100 right there for the argument t, for the variable, that will give you a positive expression for log. Therefore, that's a valid solution. Okay, here you need to start out by subtracting 11 over 2. Too much glare. So 6 minus 11 over 2, never mind, 6 minus 11 over 2. That's 0.5 or 1 over 2, or 1/2. So log base 36 of negative z equals 1 over 2. Because right here you took away 11 over 2. Now you go ahead and rewrite 36 to the power of 1/2 equals the argument. So 36 to the power of 1/2 equals the argument. And remember, the rational exponent, you can switch it back into the radical form. So the denominator is the index. The numerator is the exponent. So square root of 36 is 6 equals negative z. Then divide by negative 1. That gives you negative 6 equals z. Go ahead and check. Negative z times negative 6, that makes positive 6. That makes this argument positive. So you're good right there. Natural log. So just remember, natural log is the same thing as regular log. Regular log, that's interesting. With the base e. Okay, so think about natural log, log with base e. So go ahead and rewrite this. Base e to the power of 7 over 4 equals the argument. So base e with the rational exponent equals the argument. You're going to get an approximate value right there. Okay. E to the power of 7 over 4. You get that. So you add 7 to that, and then you divide by negative 6. Divide by negative 6. 1, 2, 5, 7. So I'm going to round up right there. So when you plug that in, we need to check, of course. So we have negative 2.1258 times negative 6 minus 7. And when you check, that gives you a positive argument right there on the natural log. Therefore, this is a valid answer. Even though your answer is negative, but when you substitute there, your argument must be positive. Ta-da. Okay. Divide by 6. That gives you log base 64 of u equals 1 over 6. And now we're going to rewrite this in exponential form. So 64 to the power of 1/6 is u. Following the example from the detail from number 3 right there. So when you rewrite as a radical, the index is the denominator, and the numerator is the exponent. So we can type that in, index 6. So 6th root of 64 is 2. So u is equal to 2. And it's positive, it's easy to check. Divide by 3. So here you're dividing a fraction by a number. So remember, when you're dividing a fraction by another fraction, it's the same thing as if you're multiplying by the reciprocal. So when you divide by 3, you can multiply by 1/3. Multiply by the reciprocal. Okay, simplify the fraction right there. So I have log base 36 of negative u equals 1 over 2. Go ahead and rewrite this as exponential. So 36 to the power of 1/2 is negative u. At this point, you already know that the rational exponent means, the radical. So it's the same thing as taking the square root of 36. The square root of 36 is 6. Because it's negative, that's going to give you u equals negative 6. Plug it in. 2 negatives make a positive on the argument. Therefore, this is true. Now the last one. When I have log with the same base on both sides, I can just go ahead and make the arguments equal to one another. And that's how we're going to go about example 7. That's the equality property of logs. Okay. Add 2v to both sides. Add 4 to both sides. 2v plus 5v is 7v. 6 plus 4 is 10. That equals 0. I will solve this by factoring. So 2 numbers that multiply to 10, and same 2 numbers that add up to 7. I have 2 and 5. So now you set each factor equal to 0. So v plus 2 is a factor. V plus 5 is a factor. Minus 2 on both sides. Minus 5 on both sides. Okay, that looks great. but I need to check to see if I get a valid answer. So let's check for -2 first. You can just plug it in. So -2 plus 5, -2 again, plus 6. Oh, I got 0. Okay, so when I check for -2, I get 0. 0 is not a positive number. So therefore, the v equals -2 is not a valid answer, because 0 is not positive. Let's check for -5. Okay, this one is positive. So -5 is a valid answer. -2 is not a valid answer. Therefore, my one solution for example 7 is only v equals -5. This one is not valid. That's all I got for you.